So good afternoon to all, and we are going to start our technical session. And in fact, the inaugural session was a bit delayed, and with a 2 minutes break, actually we are going to start our technical session now. Right now, we are going to start. Now, the technical session will be taken over by Dr. Nihar Ranjan Das. Dr. Nihar Ranjan Das is a World Bank consultant and is a geospatial technology consultant and also a NABET accredited Quality Council of India functional area expert and also the NABET coordinator for different areas. And another aspect is his academic aspect. He is a visiting professor in Shiksha Anusandhan Institute Department of Civil Engineering. He was teaching subjects like remote sensing and GIS and geospatial technology and similar subjects like that. And he has got a vast experience in application of GIS and remote sensing, particularly in the field of many fields, in fact, groundwater and environmental engineering and other fields. Many works he has done. As a consultant, he is involved in many works. Right now, I am not going to take much, and I request Dr. Nihar Ranjan Das to take charge and start his discussion. He is the main resource person. He is also the co-coordinator of this faculty development program. That's why I would like to request Dr. Nihar Ranjan Das to start the session. Thank you very much. And the session is now going to be recorded. রেকর্ডিং তো চালছে
Good afternoon to all of you. So I am Dr. Nihar Das. Well, let microphone and let it with the sound switch. Otherwise it is equally. Well,
hello.
We are going to discuss. This is actually our first technical session, and this is on GIS introduction, definition, concepts, and components, along with little GPS. Actually, we have framed this FDP within 15 sessions. It is a 5-day program, so actually we wanted to give you an idea regarding the GIS and remote sensing and its applications with at a beginner level as well as an advanced level. So we have made it a comprehensive program. So as it is a comprehensive, it is covering the comprehensive aspects of remote sensing GIS, its basic things as well as the advanced aspects, and little bit GPS, little bit regarding GPS also. Along with the hands-on, we have planned hands-on exercises. And 4 days we have planned hands-on exercises, and we have given actually 2 hours every day to hands-on exercises. And the last day we will be discussing on projects, and whatever the assignments in the first day itself. Today also in the hands-on we will be having a small assignment, and in the rest 3 days GIS exercises we will be having a output map which we will be developing, and that is the second assignment. And the third assignment is on cloud computing we will be doing. So in that regard, all of you will have to take your own location coordinates and you have to send it to us. We will be discussing in detail all these practical aspects in our hands-on session 3 after the launch. So now this is a lecture session, and in this we are going to discuss something about GIS, it's some introductory concepts about GIS and its definition, some basic terminology. So let us have those slides. I'm coming to slides. Is it visible? Slide. Is that slide visible? Okay, it is visible.
Yes, sir, visible, sir.
So I hope everybody is able to view the
Yes, sir,
slide.
visible.
And actually, in the WhatsApp group, as well as through phone, I have received a lot of queries regarding installation of QGIS and all those issues. So all these things we'll be discussing in mass. I will be discussing all these issues. You put your issues in the query during the hands-on session in the chat. Okay, in the Google Meet chat, you can put your queries, your problems, your issues, and we'll be discussing all these things in the interactive session at the end. Okay, and during the initial part of the hands-on session after launch, I will be giving you the brief idea regarding how to install, what are the issues you may face. So let us keep it to that session. And now let us discuss some basic concepts regarding GIS and its basic concepts. So what is GIS? Actually, GIS, the abbreviation is Geographical Information System. So it is a system. In fact, it is an information system, and it is Geographical Information System. So what is the meaning of this term geographical? It is not only something to do with geography, the subject geography, but geographical, it is a universal term, and it has come from geo. So these are some these are some basic concepts of this geographical information system. The basic concept is concept of spatial as well as geographical. And in fact, we have two worlds. One is imaginary world, in which we can imagine anything, whatever you can imagine, that is an imaginary world, and the actual world in which we live in, that is the real world. In this real world, whatever we see, we feel, we visualize, we encounter in our day-to-day life, all these things are real world objects and phenomena. So any feature or object existing or any phenomena or process or event occurring in this reality belongs to our real world. And the basic concept associated with these real world features and phenomena are the location or their position. The position is getting described in terms of location. So that means these real world objects and phenomena, they exist and they occur at some place, they occupy some space. From this concept of space, actually, these real world objects and phenomena, they occupy some space in our reality. They have some location. From this location, position, or space concept, the term spatial has come. So any such real world feature or phenomena occupying some space is termed as spatial. The term is spatial. It has come from space. And alternatively, the imaginary world, you can just think of what are the objects or phenomena in imaginary world. Your dream, you are dreaming. So dream is an imaginary concept. It belongs to imaginary world. But anything in the reality, like road, river, hills, the vehicles, the phenomena like rainfall, temperature, all these things belong to our real world. Actually, we experience it, we feel it, or we see it, or we visualize it. So these are real world objects and phenomena. So all these real world objects and phenomena, these are called spatial objects and spatial phenomena. And any spatial feature or phenomena pertaining to Earth's surface is termed as geographical, because we will come to that concept. Why this is called geographical? And so one thing is very clear out of this is geographical is a subset of spatial. Means in our universe, whatever real objects are there, like other planets, other satellites, these are spatial. But anything pertaining to Earth's surface, that only is geographical. Means a hill or a mountain or a river, it is existing in any other planet. is called spatial, can be called spatial, but that is not geographical. And anything, any hill, any river, any object, any road, anything, any phenomena rainfall in Earth's surface, that is called geographical object or phenomenon. So how come this is called geographical? In fact, what is the shape of the Earth? You can see here. What is the shape of the Earth? One is fake, one is real. The basic concept from our childhood is, if I will describe the shape of the Earth, we may term it as spheroid. It is just like a sphere. But in fact, is it true? No, because actually it is not exactly a sphere. It is, the real object is, the real shape of the Earth is something like this. You can see here. This is something like this. So this is the real object. Somewhere there is Himalayan ranges where it is the height is something about 10 kilometers, 9,000 or 10,000 meters, and somewhere there is in Pacific Ocean the Grand Canyon where the depression is till 8,000 or 9,000 meters or 9 kilometers. So somewhere it is depressed or somewhere it is elevated. So the actual shape of Earth is this. So can we term it as spheroid? No, not exactly it is spheroid. So what is the exact term which can describe the shape of the Earth? So here comes, see, this is the actual shape of the Earth. So what is the exact term which can best describe the shape of the Earth? Here comes the exact term, that is geoid. So you can very well see here, this is called geoid. The shape of the Earth is called geoid. So from this geoid, it is not spheroid, this is geoid. And from this geoid, the term geo came up. So anything pertaining to Earth's surface is called related to geo. So that's why the description of Earth, it is called geographical, and from it, the geographical information system came up. That is GIS, geographical information system. Means the system which gives us information regarding Earth. That's why it is called geographical information system. So for our mathematical or measurement or calculation purposes, we have simplified. This is actually, this geoid shape is very much irregular. Somewhere, as I have already told you, there is Himalayan ranges, and somewhere it is Grand Canyon is there. So it is a irregular shape. In fact, it is the irregular shape. But for measurement purposes, we have to fix a datum, some benchmark elevation, or as we call it, mean sea level, from which we usually compute or estimate the elevations of different places. So for these calculation purposes, we have simplified. For these calculation purposes, actually this is not the actual shape, but for calculation purposes, we have simplified the shape of the Earth to be ellipsoid, and based on that, we usually calculate the coordinates, the measurements, everything. So this is the positioning system on Earth. So how to, as we got it, that in our real world, all the objects and phenomena have a basic property, that is location or its position. In fact, position, and position is getting described in terms of location. So how you can describe your location? So what is the basic method through which we can describe our location? So the method is the coordinates. Through coordinates, we can describe our location, or coordinate is the absolute description of our location. But another method is relative description of location. Like if I will tell you that you describe your location, you can give your coordinates, exact coordinates, may it be latitude and longitude, may it be XY coordinate, and based on that, I can reach at you. But another method is relative description of location. Just like you can describe your location through your relative location, like you can just describe your location like in which city, in which state, in which city you are. Now, if I want to reach you, you can tell me that you are in India country, Odisha state, Bhubaneswar city, and in Bhubaneswar you are at a particular place. Like you can describe that your location is at this square, adjacent to this road, within this building, within this flat, within this locality. So these are the relative description of location. So what is the basic difference between these two types of describing location? One is relative description of location, another is absolute description of location. So the basic difference between these two is the absolute description is uniform for everybody living on the Earth's surface. Means if I will give the coordinates of a particular location to a person right now sitting in USA, New York, let it be. So he can very well reach at that location just by that coordinate. But if I will tell him a relative location that I am in Bhubaneswar at CRP square, I think beyond Bhubaneswar, all other people may not know what is CRP square, where it is, how to locate it. Then I have to again describe CRP square is in Bhubaneswar. Where is Bhubaneswar? Bhubaneswar is a coastal city in Odisha. Where is Odisha? It is a coastal, eastern coastal state in India. So like this, in relative description of location, you have to define so many things. So it is a relative description of location, means you are describing the location of a particular object or phenomena in relation to other objects, like state, district, other objects. In relation to other objects, you are describing through the different spatial relationship or geometrical relationship with other objects, like through adjacency, through containment, you are describing your locations. But in case of absolute description of location, you are just describing your coordinates through which you are able to reach at them. It's a PowerPoint file. That PowerPoint file is to be shared. That is for the assignment. There is in, I think, in GIS class, no? No, got it. That is a GIS assignment. It has been written. Today they will have to complete it. So I will be discussing that in mention. Is it open? 3 slides are there. So I was just discussing about your assignment. Today you have an assignment, so you all have to complete that. That is a very small assignment, but through that we will be learning something regarding georeferencing. So well, we will discuss that in hands-on class. So what we are discussing, that is the concept of location. Description of location in 2 ways. That is, one is absolute description of location, another is relative description of location. So the absolute description of location is being described in terms of latitude and longitude. And what is this latitude longitude coordinate system? Is there any other coordinate system? In fact, when the physical lecture classes are going on, we usually receive the responses from you, from all the participants. And I hope all of you must be knowing different description of coordinate systems, like XY coordinate system. It is a localized coordinate system. Means if I will tell amongst you people are there, or something around 200 people are there, amongst you, if I will tell one by one, that describe your coordinates. So all of you can describe your coordinates. So someone will describe XY coordinates, another person will describe XY coordinate. But what is the 0, 0 means origin for each of you? So for one of you, the origin is at your corner of your location, corner of your plot. And for another person, it is somewhere else. So the localized coordinate systems having different positions, different origins, different 0, 0, different origins, it is not suitable for us, because it is again just like relative coordinate system, relative description of location. In localized coordinate systems, your coordinate system is localized to your area, your system, and through that, if you will describe your coordinates, then some person, even I am, when concerned, I cannot reach at you, because I have to get to know about what is your origin first. So it would have been better if we will have a standardized coordinate system in which the origins, the 0, 0 for everybody is same, uniform. And that's why this concept, this latitude longitude coordinate system, it is a global coordinate system, global positioning coordinate system it has come up. In this, for Earth, the 0° latitude is at a fixed location, and the 0° longitude is fixed, uniform. And it is same for everybody residing on Earth's surface. May it be a person in Maharashtra, may it be a person in Tamil Nadu, Telangana, Andhra Pradesh, Odisha, Bhubaneswar, or USA, New York, Australia, New Zealand, everybody. For everybody, it is uniform. So, what is the latitude? The imaginary lines for describing coordinates, the imaginary lines extending from east to west or west to east, and the imaginary lines extending from west to east and increasing or decreasing from north to south. You can see this is the latitude. This is 0° latitude. The 0° latitude, what is it called? It is called equator. So the imaginary lines, you can see here, this is called equator. So the imaginary lines extending from west to east. In fact, you must know, I think all of you must be knowing that on a paper representation or map representation of Earth's surface or part of it, the top is always north, the bottom is south, the right side is east, and the left side is west. So the imaginary line extending from west to east and increasing from north to south is called latitude. So it is, this is 0° latitude. This is extending from east to west, but increasing from north to south means if this is 0°, then upwards it is increasing. This is 30°, this is 60°, and then this is 90°. So maximum latitude is 90° north or 90° south. The south is here, the north is here. So these are latitudes. And the longitude, the 0° longitude is somewhere passing through Greenwich, London, from where the timeline is being calculated. And in the east direction, maximum 180°, and in the west direction, maximum 180°. So total 360° longitudes are there. Maximum 0° to 180° east or 180° west. So longitude is a line, imaginary line, extending from south, north to south, but increasing or decreasing in east-west direction. So just imagine, if we are going to present this three-dimensional Earth surface or part of it on a two-dimensional paper or in our computer screen in GIS, then how the latitude and longitude will be described in X, Y coordinates. In X coordinate, what will be represented, and Y coordinate, what will be represented. So just draw a XY coordinate here like this. So I think all of you are now very clear that in which axis what is to be taken. So in x-axis, what is to be taken? Definitely longitude. Because if in x-axis whatever variable we are taking, it is increasing or decreasing in this xy direction, in this direction. So in this direction, what is increasing or decreasing? In this is the direction, means this is the east-west direction. So longitude is extending from north to south, but it is increasing or decreasing from east to west. So it will be taken in x-axis. And the latitude, it is extending from east to west, but it is increasing or decreasing from north to south, means y direction. So in y-axis, latitude will be taken. So this is the basic concept, how the coordinate is being represented. And why this latitude longitude coordinate system? Already we are very clear. It is a global coordinate system. It is uniform. Its origin 0, 0 is uniform for everybody residing on Earth's surface. So we are referring to this system for positioning. So this is latitude longitude coordinate system, and this is Earth's grid. This is global coordinate system. Well, so what are the other terminology? In fact, this program is on remote sensing and GIS. So what are these remote sensing and GIS? These are some kind of information systems. GIS is geographical information system. What are the other parts of this? In fact, there are other terminologies which describe nowadays, and based on which various courses are there in different universities, different colleges all over India, all over world. So various terminologies applied to this combined GIS and remote sensing. this is a simple term, remote sensing and GIS. What other terminologies include geomatic engineering, geomatics, geoinformatics. So these are some other terminologies. And what are the components, what are the parts of this remote sensing GIS study? The first part is the cartography. This is cartography. And what is cartography? This is the science of making maps. Means in GIS, some kind of output we derive in the form of maps. That is not only the output. In fact, GIS is a dynamic system, digital dynamic system. But in most of the cases, we derive some outputs in the form of maps, static maps. And the science of making maps is called cartography. And GIS itself, the graphical information system. Another part is the collection of data, how the data will be coming regarding coordinates, because GIS is something to do with the real world features and phenomena, which is having the basic property is location. So that basic property location, which is being described in terms of coordinates, that is the basic aspect, basic data, preliminary data, the baseline data for a GIS to start with. So how the coordinates will be, we will be getting, what is the source of these coordinates, what is the source of this data? So the primary source is surveying and GPS. Through surveying and GPS, we can get the coordinates of different features and phenomena on Earth's surface. And another aspect is remote sensing. Through surveying and GPS, we can get it. And also through remote sensing also. Nowadays, the advancements in remote sensing means satellite remote sensing, in fact. In terms of remote sensing, this is the science of collecting information regarding Earth's surface from space. Means some satellites are there. In the later technical sessions, we will be discussing in detail about remote sensing. Professor G.K. Panda will be discussing that. However, just you must know that remote sensing is a method of getting information regarding Earth's surface from space-borne sensors. In the space, some satellites are there on which some sensors have been mounted, and those sensors collect information and provide us, through which we get the information regarding Earth's surface. And another is photogrammetry or aerial photography. It is a form of remote sensing. It is a only form of remote sensing. Nowadays, the satellite remote sensing has grown to such an extent that the dependence on aerial photography has reduced. But nowadays also, if we need micro level data, micro level mapping issues with a large scale mapping requirement, so we go for aerial photography. And what is geomatic engineering or geoinformatics or GIS and remote sensing? The various terminologies I have already told you: geoinformatics, geomatics, geomatic engineering, or geographical information system. In fact, with the gradual maturity of surveying and cartography and incorporation of technological developments like computers, GPS, remote sensing, etc. So, all this together developed as a separate discipline and created enormous scope for numerous disciplines associated with spatial study. The various terms, as I have discussed already, these are the various terms. And now let us come. We have discussed a lot about real world features and phenomena, based on which actually what is the basic premise of this geographical information system, and what is the real world features and phenomena, from which we have got the term spatial and then geographical, the basic aspect. Sometimes, in fact, geographical information system is also called spatial information system, because as already we have discussed, spatial is the term for real world features and phenomena. So some features are existing on some other planet, those are called spatial, not geographical. But when it is called geographical, if it is pertaining to Earth's surface, it is existing on Earth's surface, it is geographical. So sometimes geographical information system is also called spatial information system. And as already we have discussed, a form of GIS output is map. Basically, map was there. Map was in earlier times, and nowadays we are getting digital maps. So map is a basic output of GIS system. And what is a map? In fact, what is a map? So we must discuss this first. So we cannot view the whole world, Earth, country or state by sitting or standing up at a single location. If I will ask you right now that just go to a particular point or location in your house, whatever, wherever you are sitting, and see the whole city. Are you able to see the whole city? Can you see that? I don't think, because if I am sitting in Bhubaneswar in my own office, and if I go to the rooftop, I will not be able to see the whole city. Okay, if in a certain high-rise building, I am going to the top and I am able to see a great part of this, my city from the top. Can I see the whole state? No. But now the question arises, then how can we visualize the geographical features or phenomena? I want to visualize the whole state. I want to visualize my whole city, or I want to visualize my whole country. Now you may ask me why this is required. Why I want to see the whole state or whole city or whole country? Yes, we require this. Because without visualization, we cannot plan our activities. What kind of activities? Without visualization, we cannot plan our activities. Okay, then what kind of activities do we need to plan? Just like I am giving you one example. I want to manage my forest resources in Odisha. So I need to know where are the forest resources, what kind of forest resources, what type of forest resources are there in Odisha. Means different types of forests are there: dense forest, open forest, degraded forests, mangroves, and how they are getting degraded due to human activities. Let it be mining, let it be industries, let it be urbanization. Is it so? Is it getting affected due to mining? So I need to visualize this. And primarily, I need to visualize where are the forests throughout the Odisha. The whole Odisha is not forest. Throughout Odisha, where are the location of different forests? That I must understand. I must visualize. So how to visualize where are the forests in Odisha? So the first method is I can visit the whole Odisha and survey the whole forest resources in Odisha. How much time it will take? If I need to plan where are the forest resources and how it is getting impacted, I must visualize where are the forest resources, what are the forest areas in Odisha. Let it be water bodies. Where are the water bodies in Odisha? So we need to visualize before planning. How to visualize? The map is the best solution. The solution is a map. So what is a map? What is a map? It is a reduced representation of reality then. So in broad definition, we may term it as it is a reduced representation of reality. Means in reality, how Odisha is, we are just representing in a reduced form, in a A4 size or A2 size or A3 size or A1 size map. We are representing whole Odisha, the forest resources. So it is the exact definition I am coming up. It is the reduced representation of Earth's surface or part of it. Only this much will not do with scale, because being the scientific personnel, we must know, we must be able to measure from the map. If we are unable to measure anything, then it is useless. So what is the area, what is the distance, what are the perimeter, what are the areas of forest, and the exact area in square kilometer or square meter I want to measure. So if unless this picture, this map is having a scale, the map of Odisha is having a scale, so this is just a picture. It is just a image of picture. It is not a map. So what is a map? It is a reduced representation of reality or reduced representation of Earth's surface or part of it with scale. This is the definition, not exactly definition. This is a very much simplified definition of map. So now I hope everybody is having a clear concept regarding map, and some of our concepts like this spatial, geographical, and how geographical information system came up. And now what is a map? Already we are a little bit clear. So now let us come to spatially referenced data or geographical data. What is spatial data? As already we have discussed, what is a spatial object and phenomena? The data regarding spatial objects and phenomena is spatial data or geographical data. So what are those data? Means if I will describe the data regarding a particular hill or particular road, let it be. So it has three aspects, three properties. One is position or location. The road is having, the hill is having, or the water body is having a position or location. And the second is its attributes. Means apart from location, all other descriptions are called attributes. And another thing is its spatial relationship with other spatial objects and phenomena. Means let it be NH5. It is lying within Bhubaneswar, the containment within Bhubaneswar I am describing. This spatial relationship of this NH5 with Bhubaneswar is containment. Within Bhubaneswar it is existing. So this spatial relationship or geometrical relationship is also called topology. And other aspects regarding this road, like it is a blacktop road, or this is a Pakka road or Kacha road, it is a blacktop road or earthen road, or what is its width, what is its length, what are its other characteristics. These are attributes. These are called attributes. And the coordinates or the position of this road is, when it is described in terms of some coordinate system, means let it be latitude or longitude. So this is the position or location property. So when we are discussing about geographical objects and phenomena and the data related to this, these three things we come across. So these are the basic three properties which we will be dealing in GIS later on. So you can see this is a map. Earlier times, if I want to, I want a map of my city in large scale, I have to join so many large maps in to develop such a big map, and I have to read like this. But now, geographical information system. What is a modern day geographical information system? Earlier the map was there. You can see this is a big map. How to read it? People are relying on this to read this. So nowadays, what is the revolution? The present day geographical information system have revolutionized through information technology. What is information technology? The technology which gives you information. What is this technology? The computer technology, the laptop, the desktop, the hardware, softwares, integrated. The computer system. It is the information technology, because this technology gives you information at the fingertip. That's why this is called information technology. And this has revolutionized this mapping system, digital mapping system, because all this big map, this can be, we can very well visualize in a simple small laptop or desktop screen. And we can zoom in, zoom out, we can measure distances, areas very easily. It is a dynamic system. GIS is a dynamic system. So let us come to the real definition and concepts of GIS. These were, as already we have discussed all these things. There are some basic terminology and concepts of GIS. And now let us come to the GIS concepts and definition and concept components. So, coming to geographical information system and its components. So, is it visible? Good. So, here we will be discussing something about components of GIS. What is the information system? What is a geographical information system? Then components of GIS, and then we will discuss in detail what is a software component. So, what is a system? Okay. If I will tell you, as per the general systems theory, A system is a set of elements and processes. And just like an example, human body system. What are the components of these elements or components of this human body system? The hand, leg, mouth, different body parts. These are the elements or components of your human body system. And what are the processes? Eating, walking, all these activities you perform by the help of these elements. These elements and components are hand, leg, all these things. With these elements and components, you perform certain operations. And these operations are eating, walking, or many activities you perform daily. So, integrated these elements and the processes performed by these elements combinedly is called a system, that is human body system. So, when I am talking about a system, it is an integration of certain elements and certain processes. Now let us come to what is a GIS system. It starts with spatial planning. What is spatial planning? The planning regarding spatial objects and phenomena. Already we have discussed the spatial, what are the spatial objects and phenomena? The real world objects and phenomena. Whatever the objects and phenomena existing in our real world, all these are called spatial. And when these are related to Earth's surface, these are geographical. So spatial planning is also called geographical planning when we are related to Earth's surface. So achieve our goals by solving the various spatial problems in our real world, we need a proper planning which can give us a right decision. Just like I will give you two examples. One a small example, day-to-day life, and another a larger scale example. First example is, let us you want to purchase a shoe. A shoe you want to purchase. You are staying in a particular city, let it be Delhi, Mumbai, or Bhubaneswar. So what we will do? Which shoe store you will go? Forget about online shopping and just think about going to a shop, shoe shop. So how to go to a shop? Which shop you want to go? How you are deciding? So the basic criteria is it should be in a shorter distance, less distance you have to travel, and it should be a good shop. It should be reasonably priced. Several criteria is there. So how you know that a particular shop is like this? It is meeting your criteria. So without planning, if you will not plan that I will go to this particular store, you will come out of your home, you will travel here and there, you will waste your time, and ultimately you may not get your desires. So if you plan it that I will go to, while coming out of your home, if you will plan that I will go to this particular shop, then just come out of your home, go to that shop, purchase your shoe, and come back. So it saves your time. It gives you optimum efficiency. It is a optimization. So what is how you are planning? Based on what you will know that this shop is good. So you must have some information or data regarding what are the locations of various shoe stores. Out of those shoe stores, which brand is available in which shoe store, and which is reasonably priced, which is highly priced, which is low priced. So all this information, how do you have? You have already in your brain, because already you have visited several places in your city, and you know that in this location these shoe stores are there. Already this data is fed in your brain. It is there, and you are just analyzing. When I am asking you that which shoe store you have to go, then you are analyzing and you are finding a best decision, the right decision, based on the shortest distance, the best cost, the best brand, all these things. Based on that, you are taking a decision, the right decision. If your decision is right, then you are getting the good output. If your decision is wrong, everything is wrong. So how you are reaching at your right decision? Through planning. If you have some information regarding the different shoe stores in your city, you are planning and getting the right decision. So planning is a method the output of which is the right decision. And how you are planning? It is a chain of processes. Planning is a chain of process, starting from data collection from the real world, storing the data in an organized way to create a model, then data retrieval, accessing and manipulation to simulation, analysis, and finally presentation in the form of information. Means data is not equal to information. Information is derived from the raw data. And the right and the best information helps you take the right decision. And this chain of processes, how you performed, how you are performing, another large scale example I am giving. A small scale example I have given you. In the day-to-day life, you are purchasing a shoe. And let us have another example. Like, I want a right decision regarding forest management. Already have given. How to manage the forest? You have to know what are the problems of forest, how it is degrading, where it is degrading. The basic question is where it is getting impacted or degrading. Means what are the locations where your forest resources in your state, let it be in my state, Odisha, it is getting impacted. So first of all, I need to know or visualize or get a map of forest types in Odisha and its locations. Once I get the forest type distribution in Odisha, a map, in the form of a map, I am getting able to know where are the forests and what kind of forest where. Then I have to collect the locations of urban centers or towns and mining and industry locations. If I will superimpose all these locations on forest map and I will observe, I may get a result there near the forest, near the mining and industrial locations or urban locations, the forest is degrading from last 10 years, within last 10 years. If I will compare two different years, forest resource data, forest resource map, I can very well get it. So how to get all these baseline maps, baseline data? So data collection, then data storage, data retrieval, then analysis I am performing by superimposing one on another. And then finally, what about the information I am getting and presenting it in the form of another map. So how I am performing all these things? The various elements help me. What is the data itself is an element. Without data, I cannot analyze. Who is analyzing? The experts, myself or my colleagues. And the equipments, the computer equipments, various equipments which help us, or the survey instruments through which I collect the data. All these are elements. Through these elements, I perform this. Through these elements, I perform this chain of processes, and ultimately, I am getting some information. What kind of information? Where the forest is getting impacted. Once I get the locations of forests where the dense forest have been converted to open forest or degraded forest, I will take a decision that these are the priority areas where I should take conservatory measures or forest management measures. So for my right decision, because if I will not get where exactly the forest is getting degraded, I will deploy my resources everywhere and the program will be a failure. So to know exact locations and to focus my resources, resource utilization at that particular location where it is getting impacted, I must plan all these things through these chain of processes and these elements. So these chain of processes and elements, as these chain of processes and elements gives us information, this is called information system. And more appropriately, these are called geographical information system because forest is a geographical object. And forest degradation, forest, the adverse impacts on forest, these are geographical phenomena. So this is an information system, this is geographical information system. So what geographical information system is giving us? It is giving us some kind of appropriate information which helps us in taking a right decision. So in the whole process of spatial planning, we need a right decision which is derived from geographical information system. And the whole process of this spatial planning as it gives us a right decision, is called decision making. This is a process of decision making because this finally generates the composite information for the support of decision making. So to take a right decision, we need this total decision making process, which is also called spatial planning or geographical planning, in which information system is a major part, which plays a major role. And so here we can note down a term SDSS, that is called Spatial Decision Support System or Decision Support System. As this information system or geographical information system, this is called geographical information system. As this information system or geographical information system, it supports decision making. It is also called decision support system or spatial decision support system. So the basic concept, the basic terminology, we got that GIS or SDSS, Spatial Decision Support System, or it is this DSS, Decision Support System. Now let us come to the components of GIS. Already we have discussed here the components of GIS. A system, the components of a system is the elements, and the whole system is the integration of these elements and the processes performed by these elements. So a GIS or geographical information system is a set of elements, 4 kinds of elements, and 4 category of processes they perform. First, number 1 is computer hardware. Without computer hardware, nothing we can do. And once we get the computer hardware, only hardware, we cannot run. The software should be there. Various types of softwares are there. The driver softwares, the operating systems itself, and the application software. And the GIS is an application software in which we perform specific applications. But how GIS will be installed? An operating system should be there already in the computer. So computer hardware is the primary component. Second component is computer software. Then spatial data. Without data, what we will analyze? The spatial data. And then finally the personnel involved. Means the experts as well as the users. Experts who will perform the analysis, who will derive the information, and then the users who will ultimately use this. So these are the elements or components. These are the 4 elements or components of GIS. And in the due course of this FDP program, we will be discussing in detail on this software and this spatial data, these 2 components. Because personnel involved, as we know, we are the users and experts, and regarding us, nothing to be discussed. But computer hardware, yes, it is a matter of discussion. But it is as we are getting the ready-made hardwares based on which, after installing the software, we are performing the GIS activities. Computer hardware is a part of specific computer engineers, and we're not entering in detail into this application side. So we will be basically discussing about software component and spatial data component. And the processes. What are the processes? The chain of processes being carried out in an information system. What are the chain of processes? All these processes, all these thousands lakhs of processes activities in information system, in a GIS, in a geographical information system, those can be categorized under 4 broad categories. What are these 4 broad categories? The first category is data collection, input, modeling, and storage. The second category is editing and manipulation, editing, management, and manipulation of data. Scientific manipulation. Manipulation means it is not a negative terminology. It is a scientific manipulation. Some kind of scientific manipulation is being carried out, and we will discuss in detail. And then analysis functions, and then final presentation of the information generated through this chain of processes. So this first we will be discussing in later classes, later sessions, the software component and spatial data component. What are the various softwares? How many types of softwares are there? And in the hands-on, we will learn in detail the software, how to handle this GIS software, and all this software and spatial data in software, what are the activities or chain of processes we will be performing. These are categorized under these 4 categories. And for carrying out these 4 categories of functionalities or activities in a software, the facilities, the tools, the buttons are there, or the menus are there. So the GIS tools can be also categorized under these 4 categories. So we will also be discussing the GIS tools under these 4 categories. Means GIS software tools for data collection, input, modeling, and storage. GIS software tools for editing and management and manipulation of data. GIS software tools for analysis functions, and GIS software tools for presentation and output generation. So this is a single slide which describes the whole GIS, its components and its tools. These are the 4 components of GIS, and these are the 4 category of GIS tools. This is a broad definition of GIS, not taken from any book. This is a broad, understandable definition of GIS. What does this describe? GIS is an excellent tool to store, manipulate, analyze, retrieve, and to present the data in a geographical and spatial manner. It can hold both spatial and non-spatial data. GIS allows holding various information as separate themes. Overlay facility in GIS enables analysis of relationship and changes between different themes. At present, GIS is used for a wide range of applications, including planning, land use, and geomorphology of land and coastal areas. These are some definitions of GIS as per some famous authors. In fact, a lot of definitions are there as per several authors, and as it is an emerging subject, emerging discipline. In fact, earlier the geographical information system or GIS was just a tool. It was just a software tool for digital mapping or digital cartography. But now, with the gradualizing, it has come up as a discipline, as a separate discipline, and many things have been incorporated and integrated into GIS. How many students are in there? Participants? 18. Good. Up to 162, 89 students are there. Well, see, these are some definitions of GIS according to various authors. The first one is as per Borrow, the second is Clark, the third is Parker, and the fourth one is, I think, the fourth one is, what is this written? Fourth one? Fourth one is Aronoff. Well, and the objective is just see, whatever till now we have understood regarding GIS, now you can describe in your own language. What is a GIS? It is an information system which gives you information. What kind of information? Geographical information. Regarding geographic categories under 4 categories. The chain of processes starting from data collection, modeling, storage, then data editing, management and manipulation, then data analysis, then data presentation. So this is GIS. This is the definition of GIS. So here 4 definitions
Hello. Hello. Sir, am I
Yes, sir.
audible?
Yes, sir. Now you are audible.
No.
So your mic is
What happened?
muted. Hmm.
I think there may be some network issue.
Yes, sir. Seems like that.
Audio asla das well. So now I think all of you are able to hear me.
Yes, sir, you are audible now.
So in the hands-on session, we'll be discussing. We'll join again at 2:30. We'll start the hands-on session, and we'll start with the introduction to GIS after QGIS and understanding of maps, topographics, and georeferencing. We'll carry out a particular exercise georeferencing today, and you have to complete an assignment, a small assignment, a single-page assignment, and we'll be giving already. I think all of you have got the email already given right now. Just 30 minutes back, we have given an email. So that exercise we will do, and then in the last slide of that email, slide, and the table is there. You have to submit that table along with a map. Already I have given written there. So today itself till midnight, you have to submit it at the email ID given to you. So and in that, yes, during that hands-on session, all of you are requested to give me, if you have some queries, whatever you are giving in the WhatsApp group, all the queries you can put regarding your installation issues, your handling issues, or GIS software handling issues. You can put your queries in the chat. We'll record it. At the last 30 minutes, I will discuss all your queries. Even installation issues, I will discuss in general in the starting. And at the end, all the queries put in the chat we will be answering. Okay. Thank you all. We will join again at 2:30. Thank you.
Sir, there is any attendance link, or shall we move and come back later?
Hello, regarding attendance, I told you actually right now there is no attendance link. We are taking the attendance by logging in time and logging out time. So that is online. That is clearly the facility is there. And subsequently, we may give you a Google form through which you can give your attendance. So right now, you can leave because the session is over, and you can join at 2:30 after the lunch.
So using the same link or a new link you will share?
Using the same link, all 5 days, throughout all the sessions, same link is there. But ma'am, actually, you must have clicked on the invite, means accept the invite, so that never again you have to ask for join, then we will admit. That system will be eliminated only if you will accept the invite. Got it, ma'am?
Yes, sir. Yes, sir. Thank you, sir.
Okay, welcome.
Close. Close.
Okay, sir. Thanks, sir.
Okay, welcome, welcome.
Close कर दे। मैं सर्दी टार लगिंग करे। आज ही सर्दी टार रही हूँ। तापर जोड़े में।
हाँ भाई।
चलो लॉन्च करें। जल्दी लॉन्च करें। अब तो स्टार्ट। सुबह से नहीं लगी।
So all the participants are requested to go for the launch, and now the session ends here, and we will again join 5 minutes before the scheduled time, 2:30 the scheduled time, and it is open from 2:15 again. It is open throughout actually, all 5 days, all sessions it is open. But I will be there, and sir will be there, Dr. Nihar Das will be there right from 2:15. And you can interact, and we will start our session just at 2:30 p.m. Okay, thank you very much.
तो
ओपन अच्छी था वो मोर एटा ओपन रहे दरकार
तो हमो को
ऑनलाइन सिस्टम
रेकॉर्डिंग है
रेकॉर्डिंग होची
से रेकॉर्डिंग टा केंदे डाउनलोड होबो पकार गूगल मीट रे रेकॉर्डिंग टा हेगला जो ना गूगल ड्राइव रे ना को मैं भावते गूगल ड्राइव में गूगल ड्राइव टा खोले देखना
नेटर कौन कोई स्टॉप रिकॉर्डिंग को नहीं था तो रिकॉर्डिंग चली छी
जे कोई गले बंद हो और कोन स्टार्ट हो
रिकॉर्डिंग का चलो ओपन करे
चलो
ना अबे रिकॉर्डिंग बंद कर दो
स्टॉप रिकॉर्डिंग कर दे कोन स्टार्ट रिकॉर्डिंग कर दे अरे नहीं तो स्टॉप रिकॉर्डिंग कर दे दिस मीटिंग स्टॉप रिकॉर्डिंग
when one of the Google
stop recording,
link to the recording will be added to the event, everyone in the guest list will be given access. स्टॉप करें ना कैंसिल कर दो
स्टॉप ना क्लास सेव होगा ना नेक्स्ट क्लास गोटे क्लास